All right, welcome to The Explainer. Now, when we think about Mars, a lot of us jump straight to terraforming, right? But hold on. The very first step, that's a construction project on a scale we've never seen before. Today, we're going to dig into how an army of robots could literally build a world for us, and why those sci-fi dreams of giant mechs, well, they're giving way to a much smarter and, frankly, cooler reality.
So, let's get right into it. You know the image, right? We've all seen it in the movies. This single, massive, Gundam-style robot just striding across the Martian landscape, building entire cities with its giant metal hands. I mean, it's an amazing visual. But is it actually the best way to do it? Is it even practical?
Yeah, it's a powerful idea, for sure. But when you get down to the nuts and bolts of engineering, a totally different picture starts to emerge. The truth? It's way less about one giant hero robot and a lot more about a massive, coordinated army of them.
Okay, so let's get into the nitty-gritty. Why doesn't that single giant robot model work for a job this huge? Well, it really just boils down to some fundamental problems with physics, energy, and, specialization. And here's the problem in a nutshell. The very things that make a giant robot look so cool on screen, its humanoid shape, the fact that it can do everything, those are the exact things that make it an engineering nightmare in reality. Just walking on two legs, it burns an insane amount of energy. And every single joint is just another potential point of failure. It's that classic saying, a machine built to do everything is a master of absolutely none.
So, if one giant robot isn't the answer, what is? Well, the real power, it turns out, lies in numbers. This isn't about building one massive machine, it's about unleashing an entire army of smaller ones.
Instead of thinking about one big, central brain calling all the shots, picture something more like a colony of ants, or a flock of birds. See, each individual little unit is just following a few simple rules, but when you get them all together, they achieve these incredibly complex goals. That's the whole idea behind swarm intelligence, and it is absolutely the key to building on Mars.
And we're not talking about just a handful of robots here. No way. We're talking about a literal army. Thousands, maybe even tens of thousands of humanoid bots, something like the Optimus model, all working together. They're not just using a construction machine. See? Together, they become the machine. And this is where the practical advantages really shine. For one thing, you can pack a ton of these smaller robots onto a single starship. But here's the really crucial part. If one of them breaks down millions of miles from the nearest mechanic, who cares? The mission doesn't fail, the others just keep going. You can have hundreds of jobs happening all at once, in parallel, and they can handle that rough Martian terrain way better than one clumsy giant ever could. It's just a much more resilient, efficient, and scalable way to do things.
So, the really critical thing to understand here is that it's not just about one type of robot. It's a whole coordinated ecosystem. Think of it in 3 layers. You've got your small guys, that army of general-purpose humanoid robots doing all the detailed work. Then you have the medium tier, a fleet of autonomous vehicles for specialized stuff like bulldozing. And finally, you've got the large team, these massive, purpose-built mega machines for all the truly heavy lifting.
All right, so who's on the team? And what does everyone do? Let's break down the key players in this, well, it's like a symphony of specialized machines.
Okay, so the first priorities on Mars are actually pretty simple. You gotta dig in and you gotta build out. As you can see, mining and excavation are gonna take up almost a third of all the robotic work, and that's gonna require a whole range of specialized machines just to get the job done.
First up, let's talk about team number 1, the mining and excavation robots. Their most critical job right off the bat is to get everyone underground. Why? To get shielded from all that harsh solar radiation. So we're talking about massive, autonomous tunneling machines. Yeah, kind of like the Boring Company's tech, but fully automated. They're the ones carving out the habitats and, maybe even more importantly, mining for that crucial water ice. That stuff is liquid gold on Mars. All right, so once the ground is prepped, the next team moves in, the automated construction robots. These guys basically print the city. They're working 24/7, 3D printing buildings, assembling prefabricated modules, you name it. Humans just provide the blueprints, and these machines get to work. Here's a good way to think about it. If that Optimus swarm is like a team of individual craftsmen, these machines, they're the entire automated factory.
Now, this next team, this might be the single most important group of them all, the resource and fuel production bots. These are the ISRU robots. That stands for In Situ Resource Utilization, and they are what make everything else possible. They're like modern-day alchemists. They literally turn the Martian environment into stuff we can use. We're talking breathable air from the CO2 atmosphere, water from ice, and, this is the big one, methane rocket fuel to get starships home. This is the key. This is what makes the colony truly self-sufficient.
Of course, to keep this whole massive operation running, you need a constant flow of materials. And that's where the autonomous transport robots come in. You can think of them as the civilization's blood vessels. They're just a tireless fleet of haulers, moving resources, materials, and equipment all over the planet 24/7. No GPS needed, just local navigation, running constantly from the mines to the factories to the construction sites without ever taking a break.
And you can't forget about the sky. Even with Mars's super thin atmosphere, you've got aerial drones and hover robots playing a huge role. They're the eyes in the sky for the whole operation. They're out there surveying the terrain, scouting for new resources, and keeping an eye on those big construction projects from above. Plus, they can get to places for inspections or quick repairs that the ground bots just can't reach.
So what powers this whole thing? Well, you're gonna need a ton of energy. We're talking small nuclear reactors, mega-scale solar farms, the works. And a lot of these places are going to be high radiation zones, definitely not safe for humans. So that's where the energy maintenance robots come in. This specialized crew handles all the servicing, the cleaning, the repairs. Basically, they're the ones keeping the lights on for the entire civilization.
Okay, so let's pull back for a second and look at the really big picture here. When you put all these pieces together, what do you get? This isn't just about building a little outpost. It's about creating an entirely new kind of civilization, one that's built from the ground up on a partnership between humans and machines.
What you're looking at here is a fully integrated system. It's like a pyramid. At the very top, you have humans working with AI to set the strategy and design the future. But every single layer below that, the heavy construction, the general labor, the logistics, the resource extraction, all of it is powered by a specialized robotic workforce. See, this is the key difference. It's not just a human colony that uses some robots. This is a true mechanical civilization, a real human-robot partnership.
So, what does this all add up to? You know, we started this whole explainer with that sci-fi image of one giant robot building our future on Mars. But where we've ended up is somewhere way more profound, and honestly, a lot more realistic.
And here's the real takeaway. The goal isn't just to send one giant robot to Mars. The goal is to export an entire planet-scale robotic industrial base. Think about that for a second. We're not just sending tools to build a base on Mars. The real mission is to send a perfected automated workforce to Mars that will then build an entire world for us. It's a completely fundamental shift in how we think about this.
So what if the true giant robot on Mars isn't a robot at all? What if it's the entire planet working as one integrated machine? We started this journey looking for one big machine made of metal, but maybe the real giant here is this incredible planet-wide network. All those thousands of machines, the AI, and the humans all working together in perfect sync. Maybe the true giant robot we're building is Mars itself. Thanks for joining this explainer.